David Parastatidis from the Remote Sensing Lab, who's going to present integration.
Can you hear me now?
Yes.
Okay, thank you.
Loud and clear.
So, hello everyone. Thank you for the invitation to the workshop. I'm David Parastatidis. I am a GIS analyst and full stack developer at the Remote Sensing Lab in the Foundation for Research and Technology, Hellas. Our lab's main focus is on the climate change and urbanization and the many different ways these two impact each other. Today, I will present to you one of our Horizon 2020 projects, WEkEO, which stands for Copernicus for Urban Resilience in Europe, and how we integrated the WEkEO cloud infrastructure to help us achieve this project's goals. So it is a collaboration of 10 partners with the Remote Sensing Lab leading the project with the aim to exploit the Copernicus core services and develop an umbrella application for urban resilience. There are 6 Copernicus core services, as Andrea said previously, focusing on atmosphere, marine, land, climate change, security, and emergency-related data. In WEkEO, we combine products from 4 of these services, the atmosphere, the land, the climate change, and the emergency. And we introduce new ideas on how to develop applications across these services in the domains of climate change adaptation and mitigation, healthy cities and social environments, and energy and economy. During the progress of WEkEO, we continuously interacted with users from its case study city, which, as you can see here, were Berlin, Copenhagen, Sofia, Heraklion, Bristol, Ostrava, Basel, Munich, Vitoria-Gasteiz, and San Sebastian. We organized workshops to gather user requirements from businesses, scientific and urban planning communities. So after extensive dialogue, we analyzed these user requirements in order to provide the WEkEO applications tailored to their needs. So in WEkEO, we developed an umbrella application, the WEkEO portal, which consists of 11 individual cross-cutting applications. The applications focusing on the heat variable provide products related to the local scale surface temperature dynamics, the surface urban heat island, the urban thermal comfort, the urban heat storage, and the urban heat emissions. We have applications related to hazards and risks, the urban flood risk application, and the urban subsidence, movements, and deformation risk application. And applications focusing in the CO2 emissions, the air quality, the nature-based solutions, and the health impact from various variables such as the air quality. You can find everything related to the project in the WEkEO website. You can scan, of course, the QR code in the slide or follow the URL. Along with information for the project, you will also find there the WEkEO portal, as I mentioned, which contains all the 11 applications. Now I'm going to show you some of these applications. Yes, the video starts immediately. Okay. First, we have the local scales surface temperature dynamics application. For each application, you will find a storyboard on the left side that you can scroll, which contains information about the selected application's products, along with map visualizing them on the right. In this application, we calculate the land surface temperature maps for urban areas by combining the Copernicus Sentinel-3 thermal acquisitions, the dynamic information on the land surface from Sentinel-2, and products from the land, the atmosphere, and the climate change from the Copernicus services. Similar maps are available from Copernicus, but at 1 kilometer resolution, which makes it difficult to observe the variations of surface temperature at neighborhood scale. This QRA application compensates the spatial and temporal resolution trade-off of the satellite LSD products, providing dense time series of 100 meter spatial resolution LSD with up to 4 maps per day. So on the maps side of the application, you can see on the right the Copernicus LSD, and on the left the QRA LSD, where the resolution is much higher. You can change the transparency to have a better feeling of what's below the LSD map, where here you can see the pattern of the urban layer showing on the LSD map. You can also browse different temperature products during the daytime and nighttime, and as we have up to 4 maps per day, you can compare daytime and nighttime temperatures and go to specific dates. And here we also have aggregated temperatures to units such as urban plots, neighborhood block for specific level of analysis. Okay, going next to the CO2 emissions application. In this QRA application, again, we have the storyboard on the left, and on the map we can see the emissions for Heraklion during the whole week. We can select the emissions for the weekend only, or again for the whole week. We can also compare the emissions for different seasons, and also not included in this video, you can compare the emissions from different sources such as the vegetation, the population, the buildings, and the traffic. In this application, we combine data from the Copernicus Land, Climate Change, and Atmosphere Services together with third-party in situ data, such as from enteroviruses that we have in Heraklion. Another application is the air quality one. This QRA application provides information on pollution hotspots in the city and the sources of such pollutions. Here we can see for Sofia the NO2 concentration on the left are observed on the main roads of the city, and the particulate matter on the right. You can set the opacity as well. And you can choose between the total annual mean concentration or choose to see the concentrations coming from specific sources such as the traffic, the residential area, and the industrial area. In this application, we needed to combine data from the atmosphere, the land, and the climate change Copernicus services, along with other third-party local data. Now, to show you one of the hazards and risks applications, the urban flood risk one. Here you can find information about the flood risk for individual land use sections in urban areas, as well as the total area of flood risk per land use class. Also, the application provides maps for flood hazard zones. All the maps were produced by combining only Copernicus products from the land, the climate change, and the emergency Copernicus services. So this makes this application very easily transferable to other European cities. One last application, as I don't have the time to present all 11, is the nature-based solutions one, which provides maps of building roofs with the potential of becoming green roofs based on their physical parameters. It also provides maps for green roofs priority based on the benefits and the impact they will have on reducing the urban heat island. The application as we see, as we'll see further in the video. Yes, here provides quantitative data for the total area of green roof potential in the city. So by providing such visual and quantitative data as shown in all these applications, they can be a great tool for authorities to support the decision-making for sustainable and resilient urban development, and pointing in the right direction for finding existing or potential vulnerabilities and how to mitigate them. Now, after showing you some of the Cure applications, let's see what's under the hood and how WEkEO is involved in all this. Here is a representation of the whole Cure system workflow, starting from the top, where we have the user requirements which are needed whenever we develop any kind of application in the Cure project. As I mentioned, we were in constant communication throughout the project with the related communities of the cities. The aim was to create the services in the form of these applications, which would provide the information to support their decision-making. So in order to provide this information, we start from the input data on the left of the graph, which are coming from the Copernicus services, the Sentinel missions, and from several other third-party services. These data amount to petabytes of storage, so it is impossible to have them stored locally. In our case, we use the Copernicus Core Service Interface, or CCSI for short, to search and file this data in WEkEO cloud repositories. So each time your application is called to generate a product, it first requests the input data that it needs from the WEkEO catalog. For data that are not included in the WEkEO catalog, WEkEO also provides storage where we saved all the data from the third-party services, and we were able to access them from there when needed. Of course, its application, in order to process this input data, requires computational power and to be operational 24/7 in order to provide the data to users at any time. For this reason, we used WEkEO's cloud infrastructure to deploy the applications there. I won't go into much detail about the individual API calls and the scheduling that is needed for all these components to work together, but I will just mention that all 11 Cure applications are running in Dockers on WEkEO's cloud. So by putting them there, we have faster access to WEkEO's catalog and to the repositories where the third-party data are stored. And of course, we take advantage of the computational power of the cloud server for the applications to process the data in a timely manner. In the end, the end users are able to access the applications through the Cure portal as demonstrated in the previous videos and access the data. In conclusion, the expected outcomes of the Cure project were to build an online platform for combining the Copernicus core services to support urban resilience, to integrate the DIAS cloud infrastructure, where we choose WEkEO among the other platforms, create uniform data for urban areas across Europe, gather consistent measurements across European cities, and create synergies with Copernicus core products and third-party data. Use different approaches and models to get better information for urban environments and its functions at different spatial and temporal scales, and the assimilation of users' knowledge with technical data and benchmarking. So that is all for me. You can find everything about the Cure project and everything we do in lab through this link. And of course, you can contact us if you have any further questions. That's all from me. Thank you.
Thank you very much, David. That was very nice. And there's a bunch of questions for you now.
Okay.
That project is so interesting that just sparkled a lot of interest. First, there's a few questions on like more general questions, I think that's more for me. I could just in a general response. Yeah, Sentinel 3 and 6 data that it is accessible through WEkEO. They are freely available. Yes, if you explore the catalog, once you enter in wekeo.eu, you will have access data tab, and you will see a viewer with a left-hand corner kind of all the products you can see on your left-hand side, and you will be able to select by type of satellite or by the different services, and you will see that you will find this data there. And in another general question, yes, everything that we are, so the recordings of this session and also our presentations, if our speakers agree with, we will share them with all of you, because it's indeed very interesting. And so more now, if we want to address the questions for you, David. This one did it. Yes. So first one.
Okay, because I was not sure if the previous one was for me or the general data set. So
Yeah.
for which, okay.
Still general. So yes, freely available for everyone. So for you, do you differentiate sensing the temperature of the land itself from the heat emitted by the buildings?
As I was not, the project was big. I was not involved in the creation of the applications and the science behind them. I am not sure if the application heat emissions is providing that, as I was not included this in the video, but you can go and access the application from the WEkEO website as I linked, and of course you can contact us to get you in touch with the developers and go in more detail about its application and the science behind it.
Great. Have you used any in situ data for these analyses, or you have just used the Sentinel data?
Yes. Most of the applications use in situ data. For example, for the CO2 emissions that I mentioned, we use in situ data from ecovariances. We have two of them in Heraklion. We are collaborating with Basel, which they also have towers like that. So this is one example of in situ data, and we combine them with the Copernicus core services data to create the products for these applications. So okay. Yes.
For the CO2 emission mapping, are you using land use or land use cover data?
Again, I would also guide you to the application itself, where more information about its application is described, and also you can contact me to get in touch with you with each of the developer. So I won't give you any false information right now. Yeah.
Yeah, thanks. And are the products available for all over the world?
No, these applications were specifically, as I mentioned, for several European cities. The aim was for them to be able to replicate them for the whole Europe using the Copernicus services, which again, of course, are products that are focused in Europe.
Yes, thank you. So have you used, oh, this one we have just responded to. Applications developed by Cure are only available for the cities of the project, but the processes can be replicated through or like using other products from WEkEO. Is it correct?
Yes, this is correct. Yes, you can replicate most of these processes. For other cities, of course, as I said, many of them use third-party local data, and not only the Copernicus core services. So for these applications, you would have to find similar data, but they are applicable to other cities, yes.
Okay. And I think I saw a question passing by regarding the process being available, like the process being open, like and shared, like how you the process of cure, if all of that is open and free as well, so that people can recreate it. Is that shared in the cure?
This depends for its individual application, as there were many partners and with a different level of openness. And so you have to contact each individual developer. The developers of its application are also mentioned in the website, so you can find them very easily.
Okay. Thank you. And maybe one or two more for you, but there's definitely many more. How did you access the in-situ measurement LAI? And is the system also offering to download Sentinel-2 images for that area where the LA measurements took place?
Generally, for local data, we used websites from the local authorities, or they were already available from local GIS platforms. Most of them were open for each city, but of course we were in contact with the authorities if we needed further data. And yes, we could download, of course, the Sentinel-2 images. And in our case, it was not even an issue to download them because, as I said, the applications were running in WEkEO, so we had access instant from the repositories, so we didn't have to download them locally. They were accessed through the WEkEO infrastructure.
And maybe one or two more. In the near future, will the CURE project cover other areas in pan-European region? Is that the plan?
Yes, the plan, we would hope so, to replicate these applications and maybe go further with the continuation of the CURE project to cover more cities. It's in the plans for sure. Yes, we always want to go further with what we have already achieved.
Great. Yeah, I hope we can apply it to other places. That would be super interesting to see.
Most of them were created anyway with this in mind to be easily replicated. So yeah.
Can imagine. Okay, I think we can stop for now and give the floor to our next speaker. Thank you very much, David.
Thank you very much.